See? Pretty cool.
He's one hot cop who really loses his cool. Johnny Crust.
Who's the thinnest skinned cop in history? Who's burning down below? Whose temper flares with a white hot glare like a human volcano? Well, it's Johnny Crust, and it's just cool as you please. But internally, subdermally, he's 900 degrees. Johnny Crust, you best not mock. Cause listen, bud, he ain't got blood, nor Johnny bleeds molten rock. 6 feet a cop, he just don't stop until he's made the bust. But Johnny's skin is paper thin, yeah, they call him Johnny Crust. He's Johnny Crust, better take his temperature. Cause if you ain't learned, bub, you'll get burned by Johnny's molten core.
Johnny Crust, coming this fall on the Bill Nye Television Network.
We were there for lunch.
Magma is hot. We have some magma here in our magma oven of science. When I say hot, I mean hot. This is a feather. Hot. Goofy kitchen fish mitten. Hot. A wiener. Now that is one hot dog. Now, the whole Earth is this hot, or hotter, except for a thin, cool layer that we can walk around on. That's the crust. Whoa. Yeah.
Do you guys realize what you've just been walking over? The guts of Mount St. Helens, the inside of a volcano. 40,000 years of rocks came spewing out and filled up this valley. So what we're going to do today is we're going to start monitoring the biological recovery. The volcano actually created habitat that has allowed a lot of life to come in, and come in great numbers. They're flourishing. I call this the reassembly of life, because one piece by one piece, all the players are coming back in. It's really getting interesting out in the volcanic landscape because there's so much going on.
Richie, eat your crust.
Son, eat your crust.
Hot. Volcanoes, geysers. Heat from under the Earth's crust. Hot. This is a geyser. It's just like a volcano, except instead of erupting with melted rock or hot lava, it's boiling water and steam. The energy comes from the same place, underneath the thin Earth's crust. Geothermal science!
You can make your own geyser right at home. Like any geyser, this involves very hot water, so be sure to have an adult around. Here's what you need. A heat-resistant glass funnel.
If it's glass, it has to be heat-resistant. Hence the term, heat-resistant glass.
Next, you need a pot to boil the water in. This kind of geyser looks the coolest in a glass pot. Set the funnel in the pot and get the water boiling. The tin foil acts like the Earth's crust. In a few moments, you'll have a geyser. The water boils in the bottom of the pot, making water vapor. The vapor expands and forces water out of the tube. But the water doesn't come out all at once like a hose. Instead, it pulses. It only squirts once in a while. The same is true in the Earth. Like Old Faithful, the pressure builds up and forces water out of the ground. Not that bad.
Science. Science. Science.
Hello. Today on Consider the Following, I'd like you to, well, consider the following. You and I are sitting on the Earth's crust, and it seems pretty solid, doesn't it? But now, scientists believe that the Earth's crust is actually made of plates. Not cheap plastic picnic plates like this, but tectonic plates. And tectonic is from the Latin word for build. So the Earth's crust is built of plates. Plate tectonics. And the plates are floating on the Earth's mantle, which you know is molten metal. And it's kind of like corn syrup. In fact, scientists actually use corn syrup like this to do studies of what's underneath the Earth's crust. Scientists first caught on to the idea of tectonic plates when they realized how well South America seems to fit in next to Africa. Not that bad. So take a look here. Here we have the camp stove of science. And in it we have models of tectonic plates. See, right now they're all together. And scientists believe that at one time, all the plates of the Earth's crust were one piece called Pangea. And Pangea, well, that means whole Earth, see? Not that bad. Let's say this is the Earth's crust. See, where the plates, the tectonic plates, are spreading apart, that's where we get volcanoes. And where the plates are coming together, that's where we get mountains. Now, you know, the plates are still moving even today. In fact, North America is moving away from Europe about this much every year, about 2 centimeters, about an inch every year. Well, thanks for joining us on Consider the Following.